All right, so what I'm going to do is I'm going to go through this and I'm going to show you guys I'm going to review how to name ionic compounds if you know the charge, and then I'm also going to re-explain how to name them if you don't know the charge. Now, the biggest issue that people tend to have is say, well, how do I know what the charge is? And so, well, that's why I'm here, to help out. So if you're looking at your periodic table here, Group 1 has one valence electron, and so they're going to lose that one valence electron to get to this noble gas state, this where we all want to be, and so they will always have a +1 charge, always. Okay. The group 2s will lose 2 valence electrons to have a +2 charge. And the last group that we know the charge of for the metals are these guys here, and they have a +3 charge. Now, everyone else, as far as the metals are concerned, these transition metals, all of these in orange, we do not know the charge of except for 2. There are 2 exceptions. We know this one, we know Ag. Ag will always have a +1 charge, and we know the charge of zinc, which will always be 2. So we only know this column, this column, this column, and then zinc and Ag. Otherwise, if we're having to write the name of an ionic compound and their transition metals that are not Ag or zinc, then you need to include the charge so that people know what exactly you're talking about. So let's actually go through this. In this problem, I give you Cu and O. Well, Cu is copper, so I can start out by writing copper. And then, if you notice, copper is a transition metal, and so therefore, by looking at the periodic table, it doesn't tell me what the charge is. If you notice, oxygen has a -2 charge, which means copper, in order to make this a neutral ionic compound, copper would need to have a +2 charge. So copper is going to have a +2 charge, so it's going to be a 2 Roman numeral. And then remember, to write my non-metal, I just have to write oxygen, but with an IDE ending. So it's going to be oxide. All right. So that's my first one. For Na2S, Na is right here, so I know the charge of Na. It is always +1. I can get that from looking at the periodic table, so I don't need to write the charge in. I can just write sodium because I know that you will know what the charge is. So sodium, and then I've got sulfur, so get rid of the ending and add IDE, so it's going to be sulfide. Okay. So basically the whole point is, if I give you this name right here, would you be able to know that sodium has a +1 charge? And the answer is yes, because it's in group 1. All right. For PbO2, lead's right here, so I don't know the charge of lead because it's in the + or -4 group, which is kind of funky. We don't know the charge. So all you have to do is the following. Oxygen has a -2 charge. Okay. Since there are 2 of those oxygens, oxygen as a whole is going to contribute a -4 charge, because -2 times 2 is -4, which means lead, in order to cancel out that -4 charge, would have to have a +4 charge. So when I'm writing this out, it's going to be lead. The way that you write a 4 is IV, because that means 1 less than 5, which is the V, so IV. So lead 4, and then it's just oxide. What was I going to say? I can't remember. All right, Ni2S, that's nickel, finds nickel. Oh, it's a transition metal, therefore I don't automatically know the charge. So if you look at sulfur, sulfur has a -2 charge, which means nickel as a whole, this entire thing needs to contribute a +2 charge. Now, since there are 2 nickels already there, that means that each nickel is going to contribute a +1 charge, because +1 times 2 is +2, and that'll cancel out your -2. So this is going to be nickel. The charge of it is 1. Oops. Nickel, and then I can just draw an I, nickel 1, and then it's sulfur, so it's going to be sulfide. Okay. For the next one, aluminum, if you look aluminum up on the periodic table, we know its charge always. It will always be +3 no matter what happens. And so I don't need to put the charge of it, even though I know it's +3. I don't need that information. Okay, so I can just write aluminum and then oxygen becomes just oxide. So O-X-I-D-E. Okay, for the next one, iron, if you look up iron on the periodic table, it is right here, so it's a transition metal. So I don't know the charge of it just looking at the periodic table. It would have to be in this group, or that group, or be zinc or Ag. And so as a result, I have to look at nitrogen. Nitrogen's right here. It has a -3 charge, so I can put -3 right here. Okay. Therefore, in order to cancel out the -3, iron would have to be +3. So this is going to be iron. And then it's going to be 3, 1, 2, 3, and then it's just nitride. Okay. For the next section, what I do is I'm just going to be crossing charges like crazy. So it's actually really nice and easy to write the formula. Okay, so I tell you it's cobalt 2 nitride. The reason why I needed this 2 is because you don't always know that you won't ever know the charge of cobalt unless I tell you. So you know cobalt has a 2+ charge. You know that nitrogen, looking at the periodic table, is going to be a 3- charge. So I'm going to cross my charges. So this would become CO with a subscript 3. Okay, make sure the subscript indicates how many cobalts you need. The charge is a superscript to show the charge, so it's CO3N2. So really not too bad. For the next one, calcium sulfide, the reason why I didn't include a Roman numeral is because we always know the charge of calcium. Calcium is always going to be, sorry about that, 2+. Okay. Sulfur, if you look up sulfur, sulfur is over here. It has a 2- charge, so S2-. So when I write this, I could write Ca2S2. However, I would need to reduce that. So I'm just going to write CaS. And the way that I do that, I divide both of my subscripts by 2 and get 1 from them. Okay? Lithium, again, I don't write the charge because I know it just looking at the periodic table. It's +1. The charge of oxygen is 2-. So therefore, when I cross my charges, the 1 goes there, the 2 goes there. This would just become Li2O. Okay. For the next one, you don't know the charge of lead, and therefore that's why I have to tell you it. The charge of lead is 4+, so it's going to be Pb with a 4+ charge. Okay. And then you know that the charge of sulfur is 2-. And so what you would get, this is not going to be the final answer, but what you would get would be Pb2, because the 2 comes from the S, S4. But the challenging part you need to recognize, the 2 and the 4 can be reduced by dividing by 2. So that would become a 2, that would become a 1, and so my final answer is actually going to be Pb S2. Okay. For zinc phosphide, the reason why I didn't have to write out the charge in the name is because you know that the charge of zinc is 2+. So zinc is 2+. Phosphorus is, if you look, 3-, so P 3-. I'm going to cross my charges. So the 3 goes as a subscript for the zinc, the Zn. The 2 becomes a subscript for phosphide, so it's Zn3 P2. Okay. For the last one, silver, I know the charge of silver. It's +1, that's why they didn't need to give it to me. That's why I wouldn't need to write it in writing the name. Cl has a -1 charge. So the 1s become the subscripts. I don't actually end up needing to write the 1, so it's just going to be AgCl. Oops. And that's it, guys. We're done.